Networking basics. Welcome to Roy, and let's just get right into it here. So I'm going to share a screen here, and there will be a version of this slide deck available in the comments section of this video if you would like to have that in your toolkit. A lot of us have an idea of what a computer network is. It's basically just a group or two or more interconnected systems, and in order for that to work, and for them to communicate with each other, there has to be some common protocols. There are different kinds of networks that you can have, and so we'll look at a few of those details. So getting into the most common forms of computer networks or types of computer networks that you're likely to see, probably the two in the middle are the one that most of us hear about, LAN and WAN. There are other networks, and we'll review some of those. On this slide, we've also got PAN and MAN. Those are ones that I know I don't hear about really discussed, but we'll cover them just at a high level. What is a LAN? A LAN is a local area network. That's what LAN stands for, local area network, which is a group of computers or peripherals that are connected in a limited area. So that might be in your school, in your office, in your house, that sort of a thing. And on a LAN, you can share various things, including printers and gaming consoles. Characteristics of a LAN, or local area network. It's a private network, so one of the advantages there is an outside regulatory body never has control over it. The LAN operates typically they operate at pretty high speeds compared to, say, a WAN, a wide area network. So this is sort of a basic, simple depiction of a LAN, or a local area network. You see multiple devices there, and all connecting to each other. Advantages of a LAN is that you can share resources. So the same licensed software may be able to be shared using a LAN. Data that's stored on a single drive or in a single server, you may be able to share that amongst users using a local area network. And it allows you to easily transfer messages. The disadvantages of LAN would be cost. While there is a cost savings component because of shared resources, the initial cost of installing a LAN can be high. The LAN admin can check personal data files of every LAN user. It may not offer good privacy. Unauthorized users can access critical data of an organization if a LAN administrator hasn't been successful in fully securing the centralized data repository or server into the local area network, requiring constant LAN administration, as there are issues related to software setup and hardware failures that necessitate active management when you are putting a LAN in place for an organization. What is a WAN? WAN is a wide area network. It's a type of network that is spread across geography, can connect LAN users. Multiple LANs can be connected. Maybe telephone lines can be connected, put in place in an enterprise or some kind of organization. And wide area networks are mostly established using higher cost telco circuits. This is more expensive than just your basic local area network. What are the characteristics of a WAN? Software files can be shared among all the users. If all can access the latest files, that's cool for collaborating. So WANs are used pretty universally in many of the organizations. This is a sample diagram of what a WAN might look like. And so you can see the internet there at the top, and routers going to these groupings of devices. And these groupings of devices, they're connecting using the internet, so they could be any distance apart, really. Could be on the other side of the world from each other. Advantages of a wide area network: they help you cover these large geographical areas. They can contain devices like mobile phones, laptops, tablets, computers, gaming consoles, just a wide variety of different types of devices. wireless network connections can be used with a variety of devices communicating in different ways. Disadvantages of a WAN is that the initial setup cost can be very high. It's difficult to maintain a WAN network, so you're going to need skilled techs and administrators to keep that up and running and troubleshoot issues. There are more errors and issues because of the wide coverage and a variety of different technologies being used together. It can require more time to resolve issues because of the involvement of wired and wireless technologies together. And wide area networks can be less secure than some other types of networks. What are some of the differences between a WAN and a LAN? So in this diagram, what we are looking at is three different LANs, and you'll see the WAN box in the center. This basically is telling us that there's three different groupings. So let's say grouping at the top, maybe that's, I don't know, Portland, Oregon. And let's say the grouping on the bottom left, maybe that's Denver, Colorado. And on the bottom right, that's Atlanta, Georgia. And together, they are networked using the internet to create a wide area network. So each of those three pods in the wide area network, each of those three cities could potentially set up servers that they're going to share files on and be connected to each other. They could set up internal websites that could share information and that sort of thing in this kind of architecture. What's a PAN? A PAN is a personal area network, which is a computer network formed around a person. So it's generally consisting of a computer, mobile phone, tablet, maybe a smart speaker / digital assistant like an Amazon Alexa or Google Assistant or Apple Siri, something like that. PAN can be used to establish communications among all of these different personal devices. Some characteristics of PAN, it's mostly personal Wi-Fi or radio frequency enabled devices within a limited area. So mobile devices, but it can also include things like cordless mice, keyboards, Bluetooth systems. This is a diagram, a simple diagram of what a PAN or personal area network might actually look like. So some of the advantages of a PAN are relatively secure and safe. It offers short-range solutions up to 30 feet and strictly restricted to a small area. Some of the disadvantages are that it may establish bad connections to other networks on the same radio frequency. Also, the advantage of the 30 feet could also be a disadvantage of only 30 feet. And another type of network is MAN, M-A-N, Metropolitan Area Network. A metropolitan area network, or MAN, consists of computers across an entire college campus or region or even a city. This type of network is larger than a LAN being mostly limited to a single building or site. This type of network could allow you to cover an area from several miles to tens of miles. Some of the characteristics of a MAN would be it mostly covers towns and cities with a maximum range of 30 miles. The most commonly used medium to connect in this type of network is fiber optic cables, although it could also be wireless. Data rates adequate for distributed computing applications. When we think about cloud computing, this is basically saying that you could do distributed computing within the metropolitan area network. That would often be done as in a college campus situation. Here is an example of what a metropolitan area network looks like. Some of the advantages of this kind of network are it offers fast communication. It uses high-speed carriers like fiber optic cables. It can provide greater access to wide area networks. The dual bus and MAN networks provide support for concurrent bidirectional data transmission. So data transferring back and forth at the same time. And It can cover most or all of a specific area, or as we said, even an entire city. This is pretty interesting. And some of the disadvantages of this type of network are that you are going to need more cables to establish hardwire connections from one place to another. In the wireless LAN, we're looking at perhaps more radio interference because of the large number of devices. And it can be difficult to make these types of networks secure from hackers. So now we've talked about some of the types of networks. Now we're going to talk about how some of the communication can play out on these different types of networks. We're going to look at a couple of different models that are used for kind of understanding what's going on and how some applications are written in different layers behind the scenes to run across these networks. So we're going to look at OSI, which is Open Systems Interconnection Model. And we're going to look at TCP/IP, which is the Transmission Control Protocol Internet Protocol. Most of us hear about TCP/IP and OSI, not as much. So let's have a look at that. OSI is a conceptual model, and it characterizes standards of how different software and hardware components involved in a network are going to talk to each other and how they're going to divide work up. There are 7 layers in the OSI model. TCP/IP also has multiple layers, but it's a 4-layer model. Another name for TCP/IP is the Internet Protocol Suite, and it is considered a foundational protocol we use on the internet today. This kind of gives us a little bit of a look at differences between OSI and TCP/IP, talking about layer 2 switches, layer 3 Ethernet switches. We're referring to the OSI model. It's commonly used in describing network communications. Data communications between different networks are not possible if there are no common rules for transmitting and receiving packets of data. So in OSI, the layer 1 is the physical layer, transmitting raw data. And then we have layer 2, which is the data link layer that defines the format of data on the network. The network layer, that decides which physical path the data is going to take across the network. Transport layer is used for transmission protocols, including TCP and UDP. Session layer maintains connections and is responsible for controlling ports and sessions. And presentation layer ensures the data is in a usable format, and is where data encryption occurs. And then 7 is the application layer. So that is the human-computer interaction layer where applications can access the network services. So this is the part that the user actually is going to see and touch. Another way of looking at this model is kind of like this sandwich, or if we were thinking about a building as multiple levels of a building. For OSI, the physical layer is responsible for physical cable or wireless connections between network nodes. Level 2 there, we have data link. Data link layer establishes and terminates a connection between 2 physically connected nodes on a network. It breaks up what are called packets of information into frames and sends them from the source to the destination. The third level is network layer. Network layer has 2 main functions. One is breaking up segments into network packets and reassembling the packets on the receiving end. The other is routine routing packets by discovering the best path across a physical network. The network layer uses network addresses, which typically Internet Protocol addresses, to route packets to a destination node. The 4th level is the transport layer, and that takes data transferred in the session layer and breaks it into segments on the transmitting end. This is responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer. Number 5, the session layer. creates communication channels called sessions between devices. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing them when communication ends. The session layer can also set checkpoints during a data transfer. If the session is interrupted, devices can resume data transfer from that last checkpoint. So this is like when your internet connection drops, when you're maybe doing an update to something. And how does the system know to reconnect where it left off? But this is a process that's going on behind the scenes. 6 is our presentation layer. It prepares data for the application layer. It defines how two devices should encode, encrypt, and compress data so it is received correctly on the other end. The presentation layer takes any data transmitted by the application layer and prepares it for transmission over the session layer. And level 7, the application layer is used by the end user. A software such as a browser or email client. Again, we talked about this being the part that you can see and touch. A few examples of application layer protocols are Hypertext Transfer Protocol, HTTP, File Transfer Protocol, or FTP, Post Office Protocol, POP, Simple Mail Transfer Protocol, SMTP, and Domain Name System, or DNS. That's what OSI is. What is TCP IP? Let's have a look at that for a second. In TCP IP, the application layer of TCP IP provides applications the ability to access services of the other layers and defines the protocols that applications use to exchange data. Transport layer, also known as the host-to-host transport layer, is responsible for providing the application layer with session and datagram communication services. The internet layer is responsible for host addressing, packaging, and routing functions. The network access layer, or link layer, is responsible for placing the TCP IP packets on the network medium and receiving the TCP IP packets off the network medium. When a user requests to browse a website on the computer in the TCP IP model, the remote server software firstly gives the requested data to the application layer, where it is processed from layer to layer, down with each layer performing its design or designated functions. The data is then transmitted over the physical layer of the network until the destination server or another device receives it. At this point, the data is passed up through the layers again, each layer performing its assigned operations until the data is used by the receiving software. So in summary, the TCP IP model and the OSI model are both conceptual models used for description of all network communications. TCP IP itself is also an important protocol used in internet operations. Generally, when discussing layer 2, 3, or layer 7 in which a network device works, it's referring to the OSI model. TCP IP model is used for both modeling current internet architecture as well as providing a set of rules that are followed by all forms of transmission over the network. Well, that concludes our network basics, going into the different types of networks, as well as going into the different types of protocols used across those networks, and a little bit about how applications interact with each other. So I hope you found that useful. And again, you'll find a link to the slide deck in the description of this video.